All right, hey everyone. Good morning or good afternoon, whenever you're watching this. Today is going to be a relatively light lesson. We're going to be talking about graphing sine and cosine functions. Aim is how do we graph the sine and cosine functions. Homework is going to be number 20. It's going to be on a handout, numbers 4 to 10. And yeah, don't mind that. That's just a note for myself. It was page 429 in the old textbook. All right, for your objectives, we're going to graph these sine and cosine functions. We're going to determine the period and amplitude of the sine and cosine functions. And then we're going to transform the graphs of the sine and cosine functions by changing the amplitude, adding or subtracting a constant, or negating the function. Okay. So just an intro to the sine and cosine functions, which you've seen last year in Algebra 2. But here we're going to review it because we're going to go into more detail in pre-calc. Okay. For your new now, it's going to be complete the table. And as you can see here, it's t, sine t, cosine t, and the terminal point, x, y. And then we have the t values of 0 to 2 pi. Okay. So yeah, just because it's what you see here, right? I won't go to the slide, but yeah, if you want to copy this empty chart down to fill it out on your own, please pause the video here. Otherwise, I'll get to the answer. Okay, so yeah, here we just fill out the values that we know, right? So sine of 0 is 0, cosine of 0 is 1. Remember, sine is vertical, cosine is horizontal. And then the terminal point, right, x coordinate is the cosine value, 1, and then y value is the sine value, which is 0. So just 1, 0. And then we have pi over 2. Sine of pi over 2 is 1, cosine of pi over 2 is 0. All right, that's 90 degrees here. So terminal point for that will be 0, 1. And then sine of pi is 0, and cosine of pi is negative 1, right? Pi is on the negative x-axis, right? That's like right over here, right? T value of pi, that's over here. Okay, so negative x coordinate makes sense, negative 1, 0 y coordinate. All right, next we have 3 pi over 2, which is here on the negative y-axis. So the y coordinate there is going to be negative 1, right? X coordinate is 0. Okay, as you can see here. So 0, negative 1. And then lastly, 2 pi, which is where we started, right? That's just 0. So sine of 0 and 2 pi is 0, and cosine of 0 and 2 pi are both 1. Okay. All right, so that's your chart. If you need this solution, please pause the video here. Otherwise, I'll get to the rest of the lesson. All right, so yeah, just a few notes regarding the sine and cosine functions, and then we'll walk through some examples. But yeah, let me get to the slide for that. All right, so the functions sine and cosine have period 2 pi. Okay, so sine of t plus 2 pi equals sine of t. Same thing for cosine. Cosine of t plus 2 pi equals cosine t. And what this is essentially saying is if you take a t value, let's say it's 0. So sine of 0, right, we know that to be 0. If you take that same t value, plug it in here, then sine of 0 plus 2 pi is going to have the same output, the same y value as sine of 0, right? So sine of 0 is 0, and then sine of 2 pi is also 0. Same thing for cosine, right? So cosine of 0 is 1, cosine of 2 pi is also 1. Okay, so in other words, it repeats itself after 2 pi. Okay, it completes one cycle. But yeah, there you have it. So yeah, functions sine and cosine have period 2 pi. Okay, same thing as 360 degrees, right? Makes sense. It makes a full circle. Okay. All right. Next definition is the amplitude of a sine or cosine function is the height from the center line to the peak or to the trough. Trough is just a fancy word for the minimum. Okay, so let me just draw that here. So let's say you had a sine function. Okay, sorry, not drawing a scale, but yeah, you get the shape. Okay, so the amplitude is the height from the center line. Center line is here, it cuts it in half, right? To the peak, so the peak is here, or to the trough. Trough is here. Okay, so peak is here, trough is here. Okay, so the amplitude in this case will be 1. Okay, from the center line to the peak is 1. Okay, same thing for center line to the trough, it's 1. Okay, so that's your amplitude. All right, well, if you need any of this, please pause the video here. Otherwise, I'll keep moving. Okay, next we have, for the functions y equals a sine x and y equals a cosine x, the number absolute value of a is called the amplitude and is the largest value these functions attain. Okay, and note that I have an asterisk here to, direct you here. So note that this is only true for functions of the form y equals a sine x, y equals a cosine x. For y equals 3 plus 3 cosine x, the largest value attained is 6, but the amplitude is 3. Okay, so yeah, this is only true for, these quote unquote like basic functions like a sine x, a cosine x. So it doesn't apply if we like vertically shift the functions. Okay, so the amplitude is just the absolute value of a. Okay. All right, if you need this set of notes, please pause the video here. Otherwise, I'll keep moving. All right, so next is some examples, which I'll get back to the lesson for. But yeah, first we're going to graph sine t, and then we're going to graph cosine t. Okay, from 0 to 2 pi. And then, yeah, that's it. And well, I had a check for understanding question that I'll get to at the end. Okay, so first let's graph sine of t. Okay, so sine t, I'm going to fill out this table of values. So we have 0 to 2 pi. So sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and then sine of 2 pi is 1. Okay, so these are the same values as the one we had, the same values as the ones we had in the do now chart. Okay, but hopefully you know these by heart by now. Okay, but yeah, we're gonna just plot these coordinates. So okay, so like we'll have 0, 0 here, then pi over 2, 1, then pi 0, then 3 pi over 2, -1 is here, and then 2 pi 1. Okay, and then sine will look like this. Okay. All right, so if you need this solution, please pause video here. Okay, all right, so next, let me just say this. Be sure to label the t and y-axis as well as the scaling. Okay, so yeah, so by labeling the t and y-axis, so here the independent variable is t, right? So 0, pi over 2, pi, 3 pi over 2, 2 pi, right? So that's the labeling of the t-axis, and then the y-axis is 1 to -1. Okay, just FYI. All right, so next we have cosine t. Yeah, so same t value 0 to 2 pi. We know that cosine of 0 is 1, cosine pi over 2 or 90 degrees is 0. Then we have -1, then 0, then 1. Okay. All right, so for that, it'll be 0, 1, then pi over 2, 0, then pi then pi -1, then 3 pi over 2, 0, and then 2 pi 1. Okay, and this is what cosine looks like. All right, if you need this solution, please pause video here. All right, aside from that, let's get to the classwork. So this is, yeah, we just applied some transformations to this, right? But it's pretty simple, right? We just, change the y values. X values stay the same. So 0 to 2 pi. And then here, just realize that, so yeah, sine of 0 is 0, right? And then we just plug that in here. So 4 minus 2 times 0, right? So actually, let me, here, I'll evaluate here. So 4 minus 2 times 0. Okay. Okay. So yeah, as you see, right, we just evaluate change that, okay. We just evaluate the function. So sine of 0 is 0, right, and then be 4 minus 2 times 0, which is 4. Okay. And then next we have, all right, just to save space, actually, I'll get rid of that notation. Okay. But yeah, so you get 4 minus 2, well, sine of pi over 2 is 1. Okay, so this end up being 2. And then next we have sine of pi. Sine of pi is also 0. Okay, so that'll just be 4. And then next we have 4 minus 2. Sine of 3 pi over 2, we know is -1. So that'll come out to 4 plus 2, which is 6. And then next we have 4 minus sine of 2 pi, sorry, 4 minus 2 sine of 2 pi. Sine of 2 pi is 0. So that'll just be 4 minus 0, which is 4. Okay. All right, and here you see my graph. So I know the numbers are a little hard to see on the scaling. But yeah, it goes from 1.5 to 2.53, 3.54, 4.55, all the way up to 6.5 in this graph. Okay. I mean, yeah, it'll be good to, you know, include a little bit space above and below the max and min. So yeah, maybe you might want to end at 7 though. Yeah, up to you. But yeah, we'll just plot these coordinates. Okay. Okay, so 0, 4, right? X value of 0, and then y value 4, that's here. And then we go to pi over 2, which is going to be at 2. So yeah, it goes from 4 to 2. So even though it's not a negative value, it still goes down, right? So yeah, don't be thrown off by that. And oh, I forgot to, well, on decimals here, I guess they didn't have the labelings. Okay, so like we had pi over 2 here, then pi, 3 pi over 2, and then lastly we have 2 pi. Okay, but yeah, that's what your graph should look like. Okay, in terms of the labeling. Okay. Yeah. What next we were at pi, right? So at pi it's 4, and then 3 pi over 2 it's 6, and then at 2 pi returns back to 4. Okay, and this is what your graph would look like here. Okay. Okay, but yeah, make sure you have the scaling. Okay. Yeah, if you need this solution, please pause the video here. Otherwise, I'll be moving on to our cosine graph. All right. Next, we have 3 plus 3 cosine x. So let me fill in the values, or show you the calculations, rather. So cosine 0 is 1. So this come out to 3 plus 3 is 6. Then we have 3 plus 3 cosine of pi over 2 is 0. So we have just 3. And then cosine of pi is -1. So this will end up being 0. Then we have cosine of 3 pi over 2, which is 0. So that'll be 3 plus 0, which is 3. And then 3 plus cosine of 2 pi is 0. Oh, sorry, 1. My fault. 3 plus 3 is 6. Okay. All right, so those are your y values for this cosine graph. Right, 3 plus 3 cosine x. And then, yeah, just plot these points. Right, first label the axis, so it'll be 0 to 2 pi. And then for this, I had 0 to 6, is shown here. Okay. Or, well, there's also -1. That'll be, yeah, -1 for your minimum y-axis value. Okay, so first point is at 0, 6, that's here. Then we have pi over 2, 3, that's here. Then pi 0 is here. And next we have 3 pi over 2, 3, which is here. And then 2 pi 6 is located here. Okay, and this is what your cosine graph will look like. Okay. All right, if you need this solution, please pause the video here. Otherwise, I'll move on to our check for understanding. All right. So yeah, as I alluded to earlier, there was a quick question just to, you know, summarize this lesson. So what is the amplitude and period of the function y equals -2 sine x? Okay, so if you're in class, I would give you a minute. So please take a minute and think about this. So what is the amplitude and period of the function -2 sine x? Okay. All right, so pause the video here to think about it. And yeah, let me explain it now. So the amplitude, okay, so it's always absolute value of this coefficient. So it's the absolute value of -2. Okay. So the absolute value of -2 is 2. All right, so the amplitude is always positive, just like this class. Okay, so I'll say it again. the amplitude is always positive, just like this pre-calc class. Yeah, glad to have you guys here. And yeah, period is going to be 2 pi, right? Right, that's from the notes from earlier, right? So our answer is going to be 4, right? Choice 4. Amplitude is 2, right? Positive 2, and then period is 2 pi. Okay. All right, yeah, answer is 4. All right. Yeah, but yeah, just to show you, that came from here, right? Sine and cosine have period of 2 pi unless they're transformed in some way, which we'll get to in a later lesson. And then, yeah, so that's your period, and then your amplitude, it's always the absolute value. So it's always going to be positive. Okay. All right. All that being said, the homework, again, is going to be on a handout, so I'll post that on Google Classroom. But yeah, that's all I wanted to say for today. I'll catch you guys soon, and have a great rest of the day. Take care.